The unit circle, we're going to talk about the angles in degrees, radians, what is a coterminal angle, reference angles, and then the 6 trigonometric functions. We have this unit circle, and some of you have seen it before, some of you have not, but it's important, and it is really where we get our trigonometric values from. So I'm just going to go quickly over why we have those certain points on the unit circle. So for example, we have on the unit circle, we use an angle called 45 degrees always. Why do we use 45 degrees? Here we have a 45-degree angle, and across from that, I'll call this A, across from that angle is A, and across from the other 45-degree angle is B. And because those angles are the same, we can say that A equals B. That's a fact from geometry. The larger the angle, the larger the side across from it will be. I'm going to use my Pythagorean theorem. I can always use a Pythagorean theorem on a right triangle. This is a right triangle. A right triangle has a one angle that's 90 degrees. So because it's a right triangle, we can say that A squared plus B squared equals C squared. And I already said A and B are the same. So I can say, let's call it 2A squared equals C squared. And if I want to know what A is, I can say A squared is equal to C squared over 2. And A is going to be equal to the square root of C squared over 2, which is the same as C over the square root of 2. The reason we call this a unit circle is because the radius is equal to 1 unit. Now, if I take this triangle and I compare it to the blue triangles, this is my triangle here. Now it's inside of a circle, right? But I'm moving it, I'm taking it out of there. I found all the information, but if this is a unit circle, then C is the radius and C is 1. So here I can say A is equal to 1 over the square root of 2. And if I want to rationalize this, then I'm going to multiply by the square root of 2 over the square root of 2, which gives me the square root of 2 over 2. So now I know if I have this triangle where this is 45 degrees, obviously that's going to be 45 degrees because I've made a right triangle. This is 90. I can say this side is the square root of 2 over 2. This side is the square root of 2 over 2 because A and B have to be the same. And my hypotenuse is 1 because it's going to sit here inside the unit circle. So now we have 1 point on the unit circle. And the other one we use is this 30, 60, 90 triangle. So again, if I were to draw a circle, and if I call it the unit circle, that means that the radius is 1. Let's call this 30 degrees. So now I have this same triangle. I've embedded it into my circle, and there we have it. How will I find the lengths of these? In geometry, the fact that this is 30 degrees and this is 60 degrees does not necessarily mean that the 60-degree side is twice as long as the 30-degree side. That is not true. But again, we know one thing. We know that this is 1 because this is my unit circle. So the radius is 1 and that hypotenuse is 1. Well, the best thing to do to be able to actually use geometry to find the answer is I'm going to start with something that I do know something about. So here what I'm going to do is I'm going to start with an equilateral triangle. An equilateral triangle means all the angles are the same. So if I add up all the angles, they have to equal 180. So that means each one of these has to be 60 degrees. And if it's an equilateral triangle and all the angles are the same, it means that the sides across from them are the same, right? So I can say, let's call these all A. It doesn't really matter. I want to find out something about a 30, 60, 90 triangle. So what I can do first is I can bisect that angle. So I'm cutting it directly in half, which means this would be 30 degrees and this would be 30 degrees, right? And then since I've cut it in half, this length of this side is half of A. And the same, this is the other half, right? I'm going to take just this one part of the triangle. So I'm going to take just this side right here. This is 60 degrees. This is now 30 degrees. This is a right triangle. I'm going to say this is A over 2. And I know A is this hypotenuse. And because it sits in the unit circle, we're going to call it 1. And again, I'm just going to call y this y because using the Pythagorean theorem, I know that, oh, and also because I called A 1 because I'm in the unit circle, this is really the same as 1/2, right?
Mhm.
So now I have 1/2 squared, which is A squared, plus B squared, which I'm going to call y squared, is equal to 1 squared. So I have 1/4 plus y squared is equal to 1. I'm going to subtract 1/4 from both sides. So I get 1, here, let's do it like this. 1 minus 1/4 is 3/4. 1 is equal, y is equal to the square root of 3/4, which I can say is equal to the square root of 3 over 2. So now I know y is equal to the square root of 3 over 2. Here, if this is 90 and this is 60, notice how that's the shorter side. That's going to be 1/2. And the longer side is going to be the square root of 3 over 2. And we're going to see how this relates to the unit circle in a minute. I just want to get through some more definitions. So an angle. An angle consists of two rays or half lines. A ray starts somewhere and continues indefinitely in one direction that originate at a common point called the vertex. These two rays, so for example, if I were to talk about my unit circle again, and I drew, I'm going to start here at what I'll call the origin, and that's a ray. And you can even say where I started from was a ray. There's my two rays. Okay, they started a common vertex, and they have names. This is the initial side, and this is the terminal side, because I'm saying I'm going that direction. So I'm starting at 0 and I'm going to whatever that angle is. Okay. So the initial side is the side that doesn't move, which we're going to say right now is 0. And the terminal side, I'm moving this side right here into whatever angle I want, and that's the terminal side. And we usually refer to angles as lowercase Greek letters. Most often I'm going to use theta. This is theta. Alpha, beta, theta, gamma. Most of the time we'll use theta. I don't know, it's just kind of by nature I use theta, but any letter is fine. Standard position, our initial side is always the positive x-axis, and we always call this 0 degrees. And then the terminal side is wherever I go. I can go anywhere along the circle. If I want to know what the angle is, it's the angle that goes from the initial side to the terminal side. And again, I'll call that theta. If I'm going counterclockwise from my initial side, I'm going in the positive direction. And if I go the opposite direction clockwise, I'm going in the negative direction. So if I want, let's say I want positive 45 degrees, I would go here. If I want negative 45 degrees, I'm going to go here. So this would be negative 45 degrees.